Hello, good morning. So today we are going to discuss one of the most important technique in chromatography, that is column chromatography. As the word itself, it indicates the meaning, that is chromatography, that is separation of the substances, components with the help of the column. That's why it is known as column chromatography. What is the technique actually? What is the principle involved behind the column chromatography? What is the methodology? So if we see the principle of column chromatography, as we know that chromatographic separations are based on two principles, that is the partition coefficient as well as adsorptivity. So as you are observing in the slide, that in column chromatography, the requirements are, we need a glass column. Again, the selection of the glass column, their width and height, say the dimensions, again depends upon the nature of the experiment, the type of the experiment, depends upon the substances, components which we want to separate out. So selection of an appropriate glass column, then again selection of an adsorbent, that is nothing but the stationary phase. As we know that in chromatographic separations, we require two phases for the separation of components. One is the stationary phase, while another is the mobile phase. So column is just a supportive material, supportive part which supports to the stationary phase. So adsorbent, it acts as a stationary phase where the components are get adsorbed depending upon their adsorptivity. Second thing, that is of mobile phase. Again, selection of the proper mobile phase is one of the very important aspects while designing the experimental part, experimental procedure. So different types of the solvent system, isocratic, maybe of gradient one, a single solvent system or a mixed solvent system, mixture of solvents is used as a mobile phase. So as you are observing in the slide, selection of the glass column. Second part is involved in the experimental part, which is very important again, that is column packing. Column packing technique. So again, there are of two types of column packing technique are involved. One is known as the dry column packing, where another one is the wet packing. Then glass column filled with some adsorbents. Then fill the glass column with solvent, add the mixture and allow the chromatogram to develop. That means pour the solvent through the glass column on the top side of the portion and remove it in a small fraction through the column plug. One more thing in the designing of the column packing, that insert a small glass wool in the bottom side of the glass column, or simply we can use the cotton plug just to protect the adsorbent layer. If the glass wool or the cotton plug is not inserted, then the whole amount of the adsorbent layer will get removed out. So just to hold the stationary phase, that is the adsorbent layer, we need to fix a glass wool or cotton plug at the bottom side of the glass column. So this is just a very simple experimental design, that preparation of the stationary phase, that is the adsorbent, in a glass column, then add mobile phase, and then add the substances or analytes, and then develop the complete chromatogram, and then remove the analytes, separate out, and identify. Again, the identification of the different types of the analytes depends upon various qualitative analytical methods. Say for example, if it is a colorimetric estimations, if the samples, if the analytes are the colored one, we can go for the colorimetric estimations. We can go for UV spectrophotometry. We can analyze it with the help of the IR, NMR, etc., etc. These different qualitative analytical techniques. So now let us see the procedure, the theory involved in the glass in a column chromatography. So as we know that the chromatography is one of the separation techniques where the mobile phase carries the solute throughout the stationary phase and according to their partition coefficient, and here in column chromatography, here according to their adsorptivity, the substances get retained over the stationary phase, and accordingly these components are get separated out with the help of the stationary and mobile phase. So this technique was developed by the American chemist, that is Honorable D.T. Day, in 19th century. He was working on some plant pigments and he wants to separate out the different pigments from the plant extract. Again, these plant pigments, as we know that extracts of the plants, these are many times, many substances, many analytes, these are the colored ones. So it is very easy to identify the different constituents, different pigments from the mixture of the plant extract. So in column chromatography, separation as well as purification of solids as well as the liquids can be done. Separation as well as purification means for qualitative analysis also, for quantitative analysis also, we can use the same technique with the help of the stationary as well as the mobile phase. So very simply, we can explain the principle, that is the mixture of components dissolved in the mobile phase is introduced into the column. Components move over the stationary phase depending upon their affinities, depending upon their adsorptivity. So those substances which are having the high adsorptivity, they will get retained first on the top side of the glass column, whereas those substances which are having least adsorptivity value, they will retain at the bottom side as soon as you will pass the mobile phase throughout the glass column. So mainly the principle involved is of adsorption, adsorptivity. You can see here the chromatographic column. So now see the experimental details, as in a little bit just we discuss that in glass column chromatography or say